Now let's continue on question B. On its way to the planet, the spacecraft moves past a cargo ship returning to the Earth. So you can see like Earth is somewhere here, okay? This is our Earth here. And we can see that the spacecraft is moving away from the Earth, but the cargo ship is moving towards the Earth, okay? The proper length of the cargo ship is 992 meters, and its speed is this much relative to the Earth, okay? So again, this is how it's travel relative to the Earth. So someone from the Earth will see that the cargo ship is moving towards it at this speed, 0.6 times c, and it will see the spacecraft is moving away, okay? First, they ask us to say what is the proper length. So basically, this is just a theory question. I hope that you can remember and recall that the length of an object is in its own rest frame. So basically, we just have to see the length measure at the frame itself. So for example, if you want to see how long the cargo ship is to anyone in the cargo ship, then that person should stay at rest on the cargo ship, and they can see from this front of the cargo ship to the back of the cargo ship. Or if you want to see the proper length of the spacecraft, you have to stay on the spacecraft to see it. Or if you want to see the size of the Earth, like the radius of the Earth, you have to stay on the Earth to measure that length. So basically, it will be the length of an object in its own rest frame. Okay, keep that in mind. And you can also see that from the mass scheme, it just also say like the length of an object in the object rest frame. So just remember the keyword that rest frame, okay? That's just the length of the object in its own rest frame. Sounds good? Okay, let's continue. For the next question, they ask us to show that the speed of the cargo ship relative to the spacecraft is this much. Wow, okay. So, things changing here. They ask us to find relative to the spacecraft. So then we have another reference frame, right? So far, we just see like, okay, how is it compared relative seen from the Earth, but now it's seen from the spacecraft. And it asks for the speed of the cargo ship, okay? So how can we find this one? Basically, you can see that, okay, we need to find some speed, some velocity relative to some moving reference itself as well, right? Because the spacecraft is moving relative to the Earth. So then, okay, I will think of that equation right away. Just look at the data booklet and check all the equation that you can use straightforwardly, you know. So then this one, right? So what does this one mean? Let's just have a look at this one again. Basically, you will have like so we have like an S coordinate system, a reference system, and an S prime system, right? So the Earth is what we got from the beginning, right? And the S prime here is like what we need to see from that frame. So basically here, this should be the spacecraft, okay? So then you can see that on the Earth, if something is moving at a speed u, then from the spacecraft that something should moving at another different speed u prime. And then it will be on change based on this v. And what is this v? This v here is like the speed. Let me try again here. The speed of the spacecraft relative to the Earth. Okay. And we also have to pay attention, like if you can have a look back at the first video in this topic, special relativity, posted a while ago, or I can just like quickly remind you here. Then you should remember it also depends on the Earth. You should have a positive direction aside for the Earth. It's just like based on the position, you know. And then if you got the v the speed of the velocity of the spacecraft is along that positive direction, then you got the v here is positive, you know. But if you got the v is in the opposite direction, then that value of v should be a 0. Should be less than 0. Okay, so then now just have a look at our situation, a particular situation here. If we pick the positive direction, we assign the positive direction for the Earth to be towards the right, as in this diagram. Then you can see that the spacecraft is moving in the positive direction, right? That's why when I plug in the values here, I have it as a positive value. You see that one? See? Because it's in the positive direction. And in this case, then we can see that the cargo ship is in the opposite direction, right? That's why I have a negative values here. Make sense? And then do the same thing here. This should be like negative, and this should be positive. So then in the end, we got negative, negative. Everything in the numerator is negative. You got this one negative, positive. Everything here is like negative, negative, negative. Then it should be positive. So then in the end, you got this one like positive. Just like in the math scheme is shown here. You see? It shows here in the math scheme like positive there. And then in the end, you got the values of the U prime is negative. So why? It makes sense, right? It just basically means that relative to the spacecraft, the cargo ship is traveling in the opposite direction, right? It's towards the left, okay? It's towards the Earth. Then it makes sense, right? Because the cargo ship is returning to the Earth, okay? But here the question asks for the speed. And if you remember, speed is actually just the magnitude of the velocity. So speed is always a positive value. That's why we just have it just 0.946 of the c. Okay, and if you see in the math scheme, they also say like allow positive values in the numerator. Why? How can it be possible? So let's have a look here. In case that I want to assign the positive direction for the Earth to be towards the left, okay, then now the cargo ship will travel in the positive direction, right? Because it's the same direction with the positive. Because we're free to choose what kind of positive direction to be, okay? Then, now the spacecraft, it just turned out to be travel in the opposite direction. And then it got a negative values here. Then when you plug in a negative here and positive here. But then you can see again, everything in the numerator now become positive, positive, right? Positive, right? And then everything in here should be positive, negative, 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 and positive. So see, it's just like positive for this one, but it also means that positive in this direction means it's always like towards the Earth. So again, it doesn't matter which positive direction that you are assigning for your system, because basically you just have that the cargo ship is moving towards the Earth. Okay, so I hope that it's clear to you that you should remember the key thing is that the v in this equation should be how the second system is moving in relative with the original system. Okay, that's the key thing to remember. And also the speed is the magnitude, so it's always positive. Okay, let me know if you have any question. Thank you, and then we will move on to other question in the next video.